Now we are going to solve three different problems. A pull of 20 Newton inclined at 25 degree to the horizontal plane is required just to move a body placed on a rough horizontal plane, but the push required to move the body is 25 Newton if the push is inclined at 25 degree to the horizontal. Find the weight of the body and coefficient of friction. Here two cases are there. Case 1 which is when the body is pulled, right. The case 2 when the body is pushed, when the body is pushed, right. So, case 1, this is the normal, this is the flat surface and the body is resting on the flat surface, right. So, W is acting downward and Rn is acting upward, normal reaction, right, and a pull of 20 Newton is inclined 25 degree to the horizontal plane. So, this is the pulling force which is the magnitude 20 Newton and which is acting 25 degree with respect to horizontal, right. So, frictional force is acting opposite to the direction of the force applied, right. Similarly, case 2, the same horizontal plane, right. So, the same body and W is acting downward and the Rn is acting upward, and now instead of that pulling, so push required to move the body is 25, and if the push is inclined at 25 degree inclined with respect to horizontal, instead of pulling force, here the pushing force, here the force is pushing force, the magnitude which is equal to 25 Newton, and this pushing force which is inclined at 25 degree with respect to horizontal, right. The frictional force is acting opposite F, because opposite to the direction of applied force. The force is applied towards left side and the frictional force is acting towards right side, right. Now, solve case 1. This is case 1 when the body is pulled. Now, resolve the forces along the plane, which means sum of horizontal forces which is equal to 0, right. So, we know that already F which is equal to mu into Rn. This is the general formula, right. Now, force. So, here the force, applied force is a pulling force is divided into two component. One is vertical component, another one is horizontal component, right. So, this is P cos 25 degree and this is P sin 25 degree. Similarly, here the pushing force is divided into two component, right. One is 25 Newton cos 25 degree, here 25 Newton sin 25 degree, right. So, sum of horizontal forces which is equal to 0. So, F which is equal to P cos 25 degree, right. So, P which is equal to here the pulling force 20. So, F which is equal to 20 into cos 25 degree. So, F which is equal to 18.126, right. So, this is one equation. So, we can alter this, instead of F substitute mu into Rn which is equal to 18.126. So, right, this is the equation 1, right. Similarly, resolve the forces vertically, sum of vertical forces which is equal to 0, right. So, how many vertical forces? Rn and P sin 25 and W, right. So, upward forces which is equal to downward force. So, Rn plus 20 into sin 25 degree which is equal to W, right. W we have to find, coefficient of friction we have to find, W and mu we have to find, right. So, now Rn, which is equal to W minus, so 20 into sin 25, which is equal to 8.45, right. So, this is another equation, right. This is equation 2, right. Similarly, right, substitute this instead of Rn, we have to substitute this value, right. So, mu into W minus 8.45, which is equal to 18.126, right. So, this is equation 3, right. So, similarly, we have to solve case 2, right. Case 2, what is the value? Resolving the forces, the case 2 when the body is pushed, right, when the body is pushed, right. Now, resolve the forces horizontally, sum of horizontal forces which is equal to 0. Horizontal forces, how many horizontal forces here? How many horizontal forces? Push and F which is equal to 25 cos 25, right. So, F which is equal to 25 cos 25 degree, right. We know that F which is equal to mu into Rn, right. So, this is second case, that is why here R dash, right. So, instead of F, substitute the value mu into or normal reaction or n dash, which is equal to 25 into cos 25, which is equal to 22.657. So, this is one equation, right. This is equation 4. Now, sum of vertical forces which is equal to 0, right. So, vertical forces, which means Rn and Rn, which is equal to W and 25 sin 25, both are in the same direction, and now Rn dash, which is equal to W plus 25 sin 25 degree, right. So, Rn which is equal to Rn dash, which is equal to W plus 25 sin 25, which is equal to 10.565, right. So, this is equation 5, right. Substitute the equation 4 in equation, substitute equation 5 in equation 4, right. So, now mu into substitute Rn dash value W plus 10.565, which is equal to 22.657, right. So, this is equation 6, right. So, now solve equation 3 and equation 6, right. Mu into W minus 8.45 divided by mu into W plus 10.565, which is equal to, what is the value here? 18.126. So, 18.126 divided by this value 22.657, right. So, multiply this and W, which is equal to mu cancel. So, multiply, cross multiplication of this and solve this W, which is equal to 383 divided by 4.53, right. So, which is equal to, what is the value? 84.547, right. So, multiply this and simplify this equation, then finally, we got W which is equal to 383.453, which is equal to 84.547, right. So, now W, right, in Newton 84.547. Now, what they are asking, coefficient of friction, W is calculated now. Now, we need to calculate coefficient of friction mu, right. Substitute this W in any equation, right, in either in this equation or previous equation, right. Now, mu into 84.547, I am substituting in this equation, right, minus mu into 84.547 minus 8.45, which is equal to 18.126, right. So, now mu, which is equal to, what is the value, 0.238, right. So, this is the value, clear. Now, next problem, a block of weight W is placed on a rough horizontal plane surface and a force P is applied at an angle of theta with the horizontal such that the block just tends to move. Prove that the force P will be the least if the theta is equal to the angle of friction. So, now we are going to prove that theta which is equal to 5 which is equal to angle of friction. Now, we are going to prove this, right. Now, this is the just an horizontal plane, right, and the body is resting on the horizontal plane, right. So, now W is acting downward, right, and the horizontal plane surface, and the force P is applied at an angle of theta. So, P is applied at an angle of theta, right, with respect to horizontal plane, right, and normal reaction is acting upward, right, and frictional force is acting towards left side, frictional force, right. So, F which is equal to mu into Rn, we know that, right. Now, resolving the forces vertically, sum of vertical forces which is equal to 0, right. How many vertical forces? Nr, W, and the P is acting inclined. So, the P is divided into two components, one is horizontal, another one is vertical, right. So, this is P sin theta, this is P cos theta. Now, sum of vertical forces which is equal to 0, right. So, Rn normal reaction, Rn is acting upward, right. So, plus P sin theta is also acting upward, which is equal to W is acting downward, right. So, now Rn which is equal to W minus P sin theta, right. Now, resolving the forces horizontally, which is equal to 0, right. Horizontal forces how many? F which is equal to P cos theta, right. So, F we know that mu into Rn. So, mu into Rn which is equal to P cos theta, right. So, this is another equation, right, and this is another equation, clear. Now, substitute the value of Rn here, right. Now, so P cos theta F which is equal to Rn, right, mu into value of Rn which is equal to W minus P sin theta, right. So, clear. Now, we know that tan phi which is equal to mu, right. Instead of mu, now I am going to substitute tan theta, right. So, now P cos theta which is equal to tan phi into W minus P sin theta, right. So, I can write tan theta which is tan phi which is equal to sin phi divided by cos phi into W minus P sin theta, in this side P cos theta. Now, multiply this cos phi in this, right. Now, the equation is comes like this, P cos theta into cos phi which is equal to sin phi into sin phi into W minus P sin theta. Now, multiply the sin phi here, right. So, W sin phi minus P sin theta sin phi in this side which is equal to P cos theta minus cos phi, right. Now, P cos theta, this is not minus, P cos theta cos phi which is equal to So, now I can rearrange this equation right now. So, P cos theta into cos phi plus P sin theta into sin phi, which is equal to W sin phi, right. So, read this: P cos theta cos phi plus sin theta sin phi, right. Cos A cos B plus sin A sin B, which is equal to cos A minus B, right. So, P into cos of cos A cos B, cos A minus cos B, right, cos theta minus phi, right, which is equal to W sin phi, right. Now what is the value of P? P, which is equal to W sin phi divided by cos of theta minus phi, right. So, here if P is least, they said in the problem prove that P will be the least, right. If P will be the least, then what is the value of cos theta minus phi? Theta minus phi, which is equal to maximum, right. So, when P is least, then what is the value of cos theta minus phi? Theta minus phi is the maximum value. If cos theta minus phi will be the maximum when cos 0 is maximum, right, when cos 0 which is equal to 1, right. So, now theta minus phi, cos theta minus phi which is equal to 0, then theta minus phi which is equal to 0, then theta which is equal to phi, right. We proved when the P will be the least, then the theta which is equal to phi, clear. And last one, it is a different problem. A body of weight 450 Newton is pulled up along an inclined plane. So far we discussed flat plane, now we are discussing inclined plane having inclination of 30 degree to the horizontal at the steady speed. Find the force required if the coefficient of friction between the body and the plane is 0.25 and force is applied parallel to the inclined plane. If the distance travelled by the body is 10 meter along the plane, then find the work done, right. What is the formula for work done? Work done which is equal to, what is the formula? Force into distance, force into distance. We need to calculate force because distance is given, force required, right. So, now we are going to draw the free body diagram, right. So, a body of 450 Newton is pulled along the inclined plane. The plane is also inclined. Instead of flat surface, now we have to draw a inclined plane. So, this is the inclined plane. So, this is the flat surface and the inclination of the plane which is equal to 30 degree, right. So, here the body is resting on the inclined plane, right. So, the horizontal steady speed, find the force required if the coefficient of friction between the plane. So, mu which is equal to 0.25 they given, right. So, the 450 Newton weight is acting always towards downward, right, and the pulled up along the inclined plane. So, the pulling force is parallel to the plane, right, not inclination. Now, the Rn which is acting upward, this Rn is always perpendicular to the body surface, right. So, this is alpha, right, and the frictional force is acting opposite to the motion of the body, right. So, here W is acting into two component, right, one is horizontal, another one is vertical. So, horizontal component, another one is vertical component, right. So, this is W sin 30 degree because the inclination of the plane which is equal to 30 degree. So, alpha which is equal to 30 degree, right. Here W cos 30 degree. Now, resolve the forces horizontally and vertically. Now we are going to resolve the forces along the plane, right. So, which means sum of horizontal forces, which is equal to 0, right. Horizontal forces P is acting along the plane, which is equal to frictional force F plus W sin 30 degree, right. So, P which is equal to frictional force mu into Rn, right, plus W which is equal to 450 Newton into sin 30 degree, right. So, frictional coefficient 0.25 is there. So, P which is equal to 0.25 into Rn plus 450 sin 30 degree. This is equation 1. Now, sum of vertical forces which is equal to 0, right. So, upward forces. So, Rn which is equal to W cos 30 degree, W which is equal to 450. So, 450 into cos 30 degree. So, what is the value of Rn? Rn which is equal to 309.71 Newton. Substitute this Rn value in this equation, right. Then P which is equal to, what is the value? 322.42 Newton, right. Now, we need to calculate work done. Work done which is equal to force into distance. Distance is given 10 meter. Now, work done which is equal to force into distance. Force which is equal to 322.42 Newton into distance 10 meter, right, which is equal to 3224.2 Newton meter. Generally, the work done in terms of joules. So, work done which is equal to 3224.2 joules. Okay. Thank you.